Hi, I'm Alex, and today I'll be discussing with you how to run automatic tiling or MIBI run file generation. So as a bit of context, your MIBI machine requires a JSON file to identify FOVs on the slide you wish to generate. Each FOV needs info such as centroid coordinates, size, a name, and some metadata. Unfortunately, these run files are not the friendliest to look at. The massive number of FOVs and metadata fields they contain make them extremely long. So the goal is to provide an automated process which allows you to generate these MIBI run files easily. Now we offer two different types of run file generation based on the type of slide you're running. If you're running a TMA, like on the left, you'll want to use our TMA tiling notebook, Create TMA MIBI Run. However, if your slide contains a sample, such as that on the right, you'll want to use the Tiled Regions notebook, Create Tiled MIBI Run. This presentation will cover both of these scripts. So we'll begin with the TMA notebook, and when you open it, the first section will help you set the data paths. To begin, you'll want to define a standardized prefix called TMA Prefix. It's important that each file you create for this section gets named with this prefix for ID purposes. Change the cell accordingly and run it. And before running the next cell, make note of the base IO directory for TMAs, called auto-labeled TMA JSONs, found in the Documents folder of the customer ION user in the C drive. Now don't worry if you see other files here when you start, they won't affect your particular run. The first input file you'll need to create is a JSON file defining the corners of your TMA grid. This file needs to be generated using MIBI control, and make sure that when saving, you name it as TMA prefix set earlier, followed by _corners.json. This file will be saved to the downloads folder, and you want to copy it over to the auto-labeled TMA JSONs folder as described earlier. Now secondly, you'll need a JSON file defining the FOV locations on the TMA for your run, again generated using MIBI control. Make sure that you also save this file with the same prefix TMA prefix set earlier, followed by _manual.json. Like the corners file, this will also be saved to downloads, which should also be copied over to auto-labeled TMA JSONs. Finally, you'll need to find your slide image in the optical image folder of the data directory in the D drive. Let's say this is the one that I need. I'll copy it over to auto-labeled TMA JSONs, and I'll rename it using the previously set TMA prefix. So in review, the three input files we'll need are the JSON file defining the locations of the corner FOVs of the TMA, a JSON file defining the locations of the desired FOVs for my run, and the corresponding slide image. After all this is verified, you can finally run the second cell in section 1 of the notebook as is. Now on to section 2, where you'll generate the FOVs on the TMA grid based on the corner file specification. You'll want to adjust these TMA dimensions accordingly before running it, and then you can run this cell, which runs the generation and validation of the FOVs on your TMA. This leads us to section 3, which helps you resolve misnamed FOVs due to irregular TMA grid shapes. You'll first want to identify some QC parameters, which will warn you of any FOVs likely to be misnamed. And then you'll want to run this cell, which brings up a visualization like this, displaying the TMA slide with the FOV locations overlaid, as well as a couple menus for toggling and adjusting at the top, and a validation checking box in the middle. Now before moving forward, this quickly demonstrates how the zooming process works. So click the box to drag and zoom into a section, and then click the home button to zoom out. Now, if we pause on the zoomed in screen, you want to make note of the coloring scheme used. Note that the red circles represent the locations of the FOVs you define for your run, or we'll call them manually defined FOVs, whereas the blue dots represent the expected locations of the FOVs per your corner file spec, generated in section 2 of the notebook. We'll also call these automatically generated FOVs. The current highlighted mapping is shaded darker. By default, each red dot is validated against its closest blue dot. So in this case, we see that my defined R1C2 FOV, colored dark red, is indeed aligned with its expected R1C2 position, colored dark blue. You can also highlight different mappings by using the manually defined FOV menu, and if you need to adjust the naming scheme of a FOV, you can use the automatically defined FOV menu to change it. As you can see demonstrated, the colors will change accordingly. Finally, when you're done, click the Save Mapping button to finalize the renaming scheme. And that'll bring us to the fourth and final section, which allows you to apply that renaming scheme to the finalized run file. Most will be running this cell as is, since randomization can help avoid potential batch effects of acquisition order. And then run this final cell, go to your auto-labeled TMA JSONs folder, and ensure that you have this automatic run file boxed in red, prefixed with the same prefix you set at the beginning. This is a run file that you'll be using for your MIBI cohort. Now, the tiled region notebook runs similarly. Like the TMA notebook, you'll need to define data paths, and you'll also want to define a standardized prefix called tiled region prefix to use for your input and output files. Again, change it to a descriptive name and run the cell. And before running the second cell in this section, you want to make note of the IO directory for tiled regions called tiled run JSONs located in the documents folder of the customer ION user in the C drive. Again, using MIBI control, you'll need to define a JSON file containing the top left corner FOVs of each region you wish to generate over the slide. This file should be named using the prefix tiled region prefix in the notebook, followed by _region _corners.json. This will also be saved to your downloads folder, and then you should move this file to tiled run JSONs. Like TMAs, you'll also need to locate the particular slide for your run. Again, you can find this in your optical image directory in the data folder of the D drive. Let's say this is the image that I need to use. I'll copy it over to tiled run JSONs, and I'll rename it using the tiled region prefix I set in the notebook. Before running that second cell in section 1 of the notebook, make sure that you have both the region corners JSON file and the slide image you need in tiled run JSONs, and then you can run this final second cell in section 1 of the tiled regions notebook. And that moves us on to section 2, where you'll set parameters for each region before generating the FOVs. This will include verifying the coordinates of the top left FOV and the size of each FOV for the particular region, setting the FOV dimensions of the region, both number of FOVs per row and column, and setting randomization parameters. Now, one thing of note is that we do offer support for Molly points for backwards compatibility, but for these particular input fields, the vast majority of you should set these to N or 0, which will eliminate the need for Molly points in your run file. And once all that is complete, these two output lines indicate that all regions have been generated. This will lead us into section 3, which allows you to adjust each region for irregular sample shapes by deleting extraneous FOVs. So when you run this cell in this section, it'll spin up an image like this, displaying your slide, and overlaying each FOV on the slide, color-coded by the region they belong to. For each region, you can propose or unpropose FOVs for deletion by clicking on them as such, and then click Delete Selected FOVs to remove them from the run file, which will also remove them from the image. And quick side note, the same zoom functionality exists for this as does the TMA name resolver. Finally, when you're done, click Save Mapping to finalize the run file. And in tiled run JSONs, you'll want to look for a tiled region mapping JSON file with the same tiled region prefix you set earlier. This will be the run file you'll use for your MIBI cohort. And that about concludes it. Thanks for listening to the presentation.